Hello and welcome to this .NET Nugget session. It's one in a series of short sessions where we spend 5 or 10 minutes looking at how we can do things with Visual Studio and the .NET framework. My name is Mike Talty and I work in the Developer and Platform Group at Microsoft in the UK. And this is one of a series of nuggets around the Windows Communication Foundation, which is a distributed application technology that's part of WinFX. And in this particular session, we're just going to spend a couple of minutes looking at how we can play with message encodings within the Communication Foundation. The idea behind encodings is that when a message flows from one piece of software to another using the Communication Foundation, firstly, it has to reach an XML format. So it might be that it starts off live as an XML format, or it might be that it starts off as an object format and we serialize into XML. And we've got a number of choices explored in a previous session as to how we can do that serialization into XML from an object. Once it's in XML though, we have to decide how to actually encode it to put it onto a communication channel between the sender and the recipient. And we don't have to encode that XML as text. Instead, we have a number of choices to how we can encode that thing. And those choices range from the most open and standard way of doing things through to more performant and proprietary ways of doing things. Here we are in Visual Studio 2005 and I'm working with the September preview of the WinFX. And what I've built here are just two very simple applications, a service and a client. And what they do is the two applications are Windows Forms applications, and the client allows me to select a photograph from the disk somewhere, and then I've just got a send button which sends it over to the service, which then displays it. And that's the application. The way in which we've built this is we've just gone and designed ourselves a service. You can see that if you've been following previous sessions, we've defined ourselves a service contract with an operation that just receives that photograph as a lump of binary. And on the client side, obviously, we've built a proxy and we've consumed that interface. Now, at the moment with my service, the way that I've got it configured is that we're using the basic HTTP binding, which simply means XML, SOAP, and WSDL over HTTP in accordance with the WSI basic profile. And we're just using that to transfer the messages from client to service. And you can see, if I just switch to my tracing tool for a minute, that the message that we just did the exchange on is simply HTTP protocol with a SOAP envelope stuck into the request stream, and that the binary photograph we just transferred is just encoded as base64, and that's how it's sent to the service. So very simple stuff. Now we can change this and take control over this encoding. If we pop back to our service for a second and just bring up the config file, at the moment we're just using the basic HTTP binding. We're configuring it using this empty bit of configuration right now. But we can take control of the message encoding and we can specify, as you can see, text, which is what we're already using, or MTOM. Now if you've not come across MTOM before, this is the Message Transmission Optimization Mechanism, which is quite a long expansion of that acronym. And really what it's about is optimizing the transmission of binary inside of a SOAP message. It works in such a way that the binary looks to be inside the body of the SOAP message, even though it's actually passed a different way, depending on the transport you're using. And we'll see kind of what that looks like in a second. So if we go and configure the same thing on the client, let's just go and visit the config file for the client and change once again that message encoding. Choose MTOM there. Just save those config files and rerun. Again, select a photograph, send it across to the service, and we'll go and look at our tracing output. Then this time around what we'll see is that the transmission of the data from the client to the service is done differently. Essentially using this protocol called XOP or ZOP, and that's an XML optimization protocol, and you would spot that the SOAP envelope is here, and what we've essentially done is put in a sort of link, if you like, a pointer to a location in the transport where the binary actually exists. So we just change the way that this binary flows across this boundary just by visiting that configuration file and changing from the text encoding to the MTOM encoding, and we don't have to touch the code in order to do this. Now, MTOM is a standard. It's a recommendation at the W3C, so you can feel fairly comfortable about using that with other implementation technologies as they adopt that standard. But there is one more encoder shipping in the box with the WCF, and that's a plain binary encoder. Now, you might spot that here, when we went to our IntelliSense, we didn't get an option for binary encoding, and that's because normally you wouldn't really pair this with HTTP. It wouldn't be very friendly to somebody who was talking to your service. But if you want to do it, you can do it, and the same thing will be true for other transport protocols that are available. So what we'll just do is visit the service configuration here, and what we'll say we're doing is, rather than using the basic HTTP binding, what we'll use is the custom binding, and we'll make that custom binding down here. And what we'll put into that custom binding is the HTTP transport, because that's what we're using. And we'll also put into there the binary message encoding. So you can kind of consider these two things as sitting on top of each other. First we encode and then we transport. We'll just give that a name. And we'll go and visit the client and do the same thing. Now on the client here, we're just going to use a few extra configuration settings just so that we can have our messages traced by that trace tool I showed you a second ago. And we'll rip out the binding that we started with. And we're good to go. It's about at this point as we rerun these two pieces of software and get them just to talk to each other again. That the message that have been exchanged this time is using a different format altogether. So we got just a big lump of binary on the HTTP post here, and similarly coming back. So the idea is that the actual way in which things are encoded onto the wire is configurable with the WCF. We don't have to assume that because we're thinking in terms of XML, that XML ultimately goes out onto a network or anything like that. We don't have to do that if we don't want to, but also we can do that if that suits our purpose and we want to be open and friendly with the rest of the world. It's a very powerful thing that we've got that configuration. Just to summarize here, we've just seen that we can play with the encoding of messages as they travel from service to service, if you like, through the WCF. We can pick a text encoding, which is going to be the most open way of encoding SOAP messages. We can pick an MTOM encoding, which is similarly open, that's a standard. And we could also choose a binary encoding, which is not standardized and would just be a proprietary way of doing things. And it's a simple config choice. It doesn't affect our code. We don't have to hack any lines of code. We just change a config file and configure the same service or different services for whichever of these encodings we want. Okay, where would you go if you wanted to get some more information on the Windows Communication Foundation? Well, the best place to start is up at msdn.microsoft.com/winfx. And if you want to find some more information about the protocols, the web service open standard protocols that the Communication Foundation is capable of using, a good place to go for that would be msdn.microsoft.com/webservices. And that particular link we have on the slide here, /understanding, there's a great document there that specifies how all these things fit together to make a distribution platform as opposed to just a random set of specifications. And finally, if you want to follow up with anything you saw in this little session, feel free to drop me an email. My address is there on the screen. It's just mtolty@microsoft.com. Other than that, thanks very much for